All right, guys, as we were just looking at these angles and the ratios for them. All right, Ms. Waysome, as you were explaining to us before, so I would like you to continue with your explanation for the benefit of Ms. Brown. Just give a little time because they are just entering the classroom, all right? All right, so in the meantime, while we're waiting on Ms. Brown to get in, I would like somebody else to just tell me what the cosine ratio for the angle C.
Sir, B over AC.
All right. Cos of angle C. What was that, Miss Cabrera?
Sir, BC over AC.
BC over AC. Is Miss Brown back as yet? No, I'm not seeing Miss Brown. It seems like she's having difficulty with her connection. All right, somebody else want to tell me what is the tan of angle C?
Sir, were you calling me?
Miss Waysome?
Yes, sir.
No, I wasn't calling you at all. But
okay.
Would you like to just give us the tan ratio for angle C?
Yes, sir.
Right.
AB over BC.
It's really so awkward in writing with this instrument. So we say that that would be AB over BC. All right, so far everybody would have an understanding except for Miss Brown, who we are waiting to get back in so that we can give her an explanation. So in the meantime, while Miss Brown is trying to get back in, now, is there any question that anybody wants to ask about these ratios? Is it clear how to write the ratios of the acute angles? All right, one of the things that I want you to notice in terms of the ratios for the angle A and the ratios for the angle C. Is there any comparison that you can make with these ratios, those with angle A and those with angle C? Can you make any comparison with them?
Yes, sir.
All right, what do you notice?
Sir, so far I realize that the cosine is opposite. Angle A cosine is opposite to that of angle C is the sine.
So the angle A cosine.
Yes, sir. And the same thing for angle A sine with the tan of angle C. And then the tan.
Sine.
Yes, sir. the tan of angle C.
The angle A is sine.
Yes, sir.
Or the cos.
The tan.
Yeah,
Oh,
sure.
sorry, sir. Yes. BC over 8, right, and then the tan, both tan.
What about tan now?
The tan angle A is opposite to that of tan angle C.
Well,
In
terms of the ratio, we would say one is the inverse of the other.
Okay, sir.
So that is something to bear in mind. So what this tells you, if you know the sine of angle A, you can determine the sine of angle C because it should be the same. Sorry, the cos of angle C should be the same as the sine of angle A. And the cos of angle A should be the sine of angle C. So if you bear that in mind, if you know the sine of one of the acute angle, you would be able to determine the cosine of the other acute angle. And if you know the tangent of one of the acute angle, you should be able to find the tangent for the other one by inverting the tangent of the known angle. All right, guys? All right, so with that said, I was hoping that Ms. Brown would be back by now, but we'll have to move on without her. All right, so with that said, guys, you should be familiar with these ratios. All right, now we want to do some observation based on the ratios. Again, one of the observations that we would have made is that if you divide the sine of angle A by the cosine of angle A, you would get the tan of the angle A. Now, is there any way that we could prove this? Can anybody prove that the tan of angle A is equal to the sine of A over the cos of A? Do you think you would be able to prove this by using the sides of the triangle? I'm going to give you about 5 minutes to try and prove it, guys. So here's the angle A. And we are saying that the tan of the angle A is equal to the sine of the angle A divided by the cos of the angle A. And so I am asking you to try and prove it using the sides of this triangle, giving you 5 minutes to try. Think about it, guys, and try to prove it. All right, guys. Anybody came up with an idea? Go ahead, Ms. Waysam. You want to walk me through the steps that you have taken and tell me what you got?
Sure, sir. Right, but I'm gonna try a thing. All right, so the tan, which is equal to sine A over cos A. So first term we have the sine A, which would have been BC over AC.
So you're saying sine A.
Yes, sir, which is BC over AC.
AC.
Times cos A. Yes, sir. Sir, just put it. Yes,
times, eh?
Sir, I don't know why me do that, but me just basically do it because and then me cross multiply and me end up getting the after me cancel out, sir. Me getting the BC over AB. So I'm not sure.
All right, so you're onto something, but to say you're multiplying.
Because we know sometimes with sir, I don't remember what the rule, but I know that sometimes when you divide, you can actually invert and get multiplication. So we that thing that.
All right, so that is really what you're doing. But what you have to now say that, well, you have to state what the cosine is. So cosine is equal to what?
The cosine would have been AB over AD.
All right, so this is sine A.
AB over AC, sorry.
All right, so this is the sine of A.
Yes,
and
sir.
We want it over the cosine of A.
Yes, sir.
It means that what we have up here is the sine of A. So we need to write it over.
Okay, I did that, but me that say it looks stupid.
So now we would have what now? What is the cosine of A?
AB over AC, sir.
So it would be AB
over AC.
Over AC.
Yes, sir.
All right, and as we can see here, this is a division bar. So we're really dividing one fraction by another. So we are dividing this fraction above by the fraction below.
Yes, sir.
So in other words, we could actually write this as equal to BC over AC divided by AB over AC. Everybody's good so far with that?
Yes, sir.
All right, so if we follow the rules when we're dividing by a fraction, what we would generally do? What is the rule for division of fraction or dividing by a fraction?
So you're supposed to invert.
Invert which one of them?
I think it's the second one. So that would be the AB over AC.
Okay, what do you call the second fraction that you're dividing by? Don't remember. It's called the divisor. So the first fraction is called the dividend. The one that comes after the division sign, which is the second one, is called the divisor. So you're going to invert the divisor, meaning that you're going to flip it upside down. But you're going to keep back the dividend as it is. So you write back BC over AC. Then now you're going to change the division sign to multiplication. Then you invert your divisor, which is this one. You're going to invert that, flip it upside down. So you put the AC. So you put AC over AB. And then now what you can cancel, you cancel. So we see that we can easily cancel AC here with AC here. And that going to leave us with what we have in the numerator. So this would be 1 over that. This would be over 1. So we multiply the numerator, BC, by 1, we get BC. And then we multiply the denominator, 1 by AB, we get AB. And then now, if we look at the side AB, or the side BC rather, so we look at the side BC, this is the side BC, and this is the side AB, so this is side AB. And if we put BC over AB, which of the ratio that we're finding in terms of the angle A? So in terms of the angle A, BC would be the side opposite, and AB would be the side adjacent. So which ratio would be opposite over adjacent? That would turn out to be the tan of angle A. So that is the tan of angle A. And that's why we say tan of angle A is equal to the sine of angle A over the cos of the angle A. Is that clear to everyone? All right. Now, for those of you who might be looking at it and say, wow, this is too much for me to deal with, you really don't have to worry about proving this because CSEC is not going to ask you to prove it, all right? The proof was just to give you an insight as to how the tan is related to the sine and the cos in terms of an equation, all right? So that's one thing to observe. So we would have proven it by following that workout process. Now, this is also another observation, and you would have seen this from in the previous set of ratios that we were finding. So we see that the sine of the angle A is equal to the cos of the angle C. So we had mentioned that before. So that's something to note. And we also know that the sine of the angle C is equal to the cos of the angle A. So these are important things to remember when you're working with the trigonometric ratios. All right. So trigonometric ratios are useful in solving for unknown sides and angles of a right angle triangle. And so that's how we're going to be applying the trigonometric ratios. Now, so what we would have known then, we would have known from Pythagoras' theorem that if we are given two sides of a right angle triangle, we can use Pythagoras' theorem to calculate the unknown side. Now, for the trigonometric ratios, if we are given one angle, one of the acute angle, now notice I'm not saying the 90-degree angle now. If we are given one of the acute angle and we are given a side in relation to that angle, and we are asked to find another side, then we can apply the trigonometric ratio that involve those two sides, all right? So this is how we use the trigonometric ratio. So whereas Pythagoras' theorem rely on having two sides of the right angle triangle, trigonometric ratio relies on having one side and an angle, which is acute angle, and it has some relation to the side. And with those, you can use it to find any of the other sides of the right angle triangle. So that's what we're going to be looking at, how to use the trigonometric ratios to do such calculations. So we're going to start out by looking at some examples with the sine ratio. Now for the sine ratio, for the first example, it says find the length of AB in the given triangle that is labeled below. All right, now if you're given this triangle here and you're asked to find the side AB, so I'm going to just use an X to label the side AB. So let's call the side AB X. All right. Now we want to find that side X. And the angle that we know is the angle C. And we know that that angle is 22 degrees. And the side that we know would be the side CB. Now the question is, which of the ratios that we can use to find, or we can use to calculate the angle X? Now we already would have known that we are using the sine ratio. So what would you do in terms of finding X if you're given this question? What would you do? Anybody? What is your approach if you were asked to use a sine ratio to calculate the value of X? And be reminded, guys, let me see the hands of those who remember to get a scientific calculator. Now, if you don't have a scientific calculator, it's going to be challenging for you, even though the scientific notations might be on your phone. I don't know if some of you would be able to access it while you're using it for class. All right, but you need to have a scientific calculator in order to work out the trigonometric ratios. All right. So anybody can start off this question for us. All right, now the first thing that you want to do, students, is to look at the side that you're trying to find and ask yourself, what relation is that side to the angle that you're given? And then now you look at the side that you know and ask yourself, what relation is that side that you know to the angle that you're given? So what is the relation with the side X to the angle C? Anybody?
Opposite.
Opposite. And what is the relation with the side 80 millimeters to the angles C?
Adjacent.
I want you to look carefully at your triangle before you decide. Angle
C, sir, which would have been 22 degrees. And then
look at the side CB.
Yes, sir.
And determine which side of the triangle that is.
CB, it runs along angle C, sir.
You see, you have to be careful.
Would it be the hypotenuse also?
You have to identify the longest side to be the hypotenuse. And remember, the hypotenuse is always across from the 90 degrees. So this side CB would not be the adjacent side to the angle C, but instead it would be the hypotenuse. So you're trying to find a side which is opposite to the angle C, and you know the side which is the hypotenuse. So now which of the ratio involve the side opposite and the hypotenuse?
Sine, sir.
Sine ratio. So the first thing that you want to do when you're solving these problems is to identify the sides, see what relationship they have with the angle that you know, and then now you write the ratio that those sides would fit into. So what is the sine ratio of angle C?
AB over 80 milliliters.
All right, so write that ratio down. So sine of angle C, you're just writing down the ratio. You're not putting in any numbers or anything. Just write the ratio. Sine of angle C would be equal to the side opposite, which is AB, over the hypotenuse, which is CB. All right, if you want to say BC, that's fine too as well. All right. Now, once you write down the ratio, now, all you're going to do is just substitute the side that you're trying to find and the value that you know for the side given. So you know that the hypotenuse is 80. You know that the side that you're trying to find is the opposite, which is X. And you know that the angle is 22. So what you're going to do now, in the ratio that you wrote, you're going to replace the C with the value of the angle. So you're going to have now sine of what is the angle? So it would be the sine of 22 degrees. Sine of 22 degrees. Now, that would be equal to the X, what that you're trying to find, over the side that you know in terms of its value. So that would be over 80 millimeters. Now, for simplicity, we don't put our millimeters in our calculation, but when we get our answer, we write in the millimeter to show or refer to it as the can somebody help me out here? What we call this again in terms of what measurement or what unit we are measuring in. So in this case, our unit would be millimeters. All right, so in terms of finding the value for X, what we have to do is when X is in the numerator of the ratio, we're just going to use a shortened method of calculating this. So I'm going to use a little shortcut. All right, what we're really doing is multiplying both sides by what is in the denominator. So if we multiply this side by 80, and we multiply this side by 80, so we would get 80 over here. So we multiply this side by 80, and we multiply this side by 80. What will happen is that this 80 will cancel out with the denominator, 80 in the denominator, and X will remain by itself on this side. All right, so over here now we would have 80 times sine of 22, And this is where now you're going to need to use your calculator to work out the sine of the angle 22. All right. Now, if you don't want to go through the process of writing the 80 on both sides, you can just think of it in terms of what we refer to as cross multiply. So what is in the denominator? We just bring it across above and multiply by what we have on the other side. So this becomes 80 times the sine times sine of 22 and that would equal to the x, the value for x. So now, if you don't have your calculator, I can't do anything to help you guys. Now, who has a calculator, scientific calculator? Mr. Lamar?
Yes, sir.
All right. So I want you to use your calculator to calculate
Yes, sir.
the sine of 22 and tell me what the value is. Do you know how to use a calculator to work out sine 22?
Sir, I do not remember.
All right, so what you want to do
Is this, sir?
is for some calculator, you would have pressed the sine button on the calculator. So look on your calculator and look for the button.
Yes, sir, I see it.
All right, so you would press that button.
Yes, sir.
Then you would put in the 22 after, and then you press equal.
So sine 22 equal?
Yes.
Yes, sir.
Do you get any value?
Yes, sir.
All right, so give me that value that you got.
Sir, on long decimal number,
Round it
0.
up to 3 decimal places.
All right,
So-
sir. So
So
3 decimal places.
we are going to write back the 80, and whatever value you calculate the sine to be, you're going to multiply the 80 by that value. All right, so let us write down the value that you get to 3 decimal places first. So what is the value, Mr. Lamar?
0.375.
0.375.
375.
And then you multiply that by 80 now.
Yes, sir, and get 30. 29.9.
So therefore, the value of x would be equal to, give me that value.
30.
30. And now we can now write our units, which is in millimeters. So x is equal to 30 millimeters. All right, and that's how you